Hello and welcome to JavaScript Marathon, a full week of free online courses in some of the leading web development technologies. Today's trainer is Nacho Vazquez. He'll be presenting on clean code lessons for the front-end developer. Welcome, Nacho.
Hey, Sarah. Thank you for having me.
We're so happy to have you. If you have any questions after today, feel free to follow Nacho at Nacho_devc on Twitter. I will drop that in the chat as we continue. A special thanks to this week's sponsor, This.Labs, offering personalized training programs to suit your organizational needs, ensuring you and your company stay on the leading edge. If you find keeping up with constantly evolving technologies a struggle and want to bring your team up to speed on one of the latest technologies, contact us today at hi@this.co to set up your complimentary needs assessment. This.Labs is hiring. If you're an engineering manager or a senior software engineer, send us your info at jobs@this.co. We're wrapping up the year with a couple more events. So next month, we have GraphQL Contributor Days on December 7th, State of Angular Ecosystem on December 9th, State of React December 14th, and our last monthly mentoring for women in tech on December 15th. We also have Angular World Tour dates. The World Tour stops in Tokyo, Japan on December 1st, and the same day, React World Tour heads to Mountain View, California. And we are back in March. So our next event is March 14th through March 18th. But our last day of JavaScript Marathon for this month is tomorrow with Anthony Fu. And with that, I will turn it over to Nacho.
Thank you. So, my name is Nacho Vazquez, and I am senior developer here at ThisDop. And today we are going to talk about clean code, lessons for the front-end developer. So the first thing that you might be asking yourself is, well, what is clean code? And the most direct answer is, well, Clean Code is a book. It's a book by Uncle Bob, and the attempt of this book is to provide some best practice and guidelines and tips for avoiding pitfalls while developing or software. So, but that said, I have a very special story with this book because at the beginning of my career, when I was yet an undergraduate, I was really a mess. My code was really ugly. I don't even want to maintain that. And a friend of mine showed me this book and suggested to me. And the title seems like was what I needed. And I started to going through the book, and there was a lot of things that I definitely take with me for the rest of my career. There are others that I didn't, that I forget. Some names, complicated jargon that I don't want to even remember. But one thing that this book teach me was that one of the most important thing, or the most important thing in software development, is practice, and it is to have like discipline while developing. But that said, what is clean code? Well, clean code is an art. So if you master writing clean code, you can call yourself an artist. But it's also a sense. It's an intuition. So if you get that to acquire that good intuition, you can call yourself to have superpowers. And mostly than all is hard work and practice, is discipline, as I mentioned, is going every day trying to make your core more readable, which readable in this sense evokes to the ability to easily understand what is happening when we are looking a piece of code. And this is very important because most of our time we are going to spend in reading code than writing. Another thing, or another characteristic that clean code has, is that it's maintainable. And maintainable is associated with readable, but it's not quite the same. You can read the code and understand the code, But even if you understand what's going on, it can be written in a way that is hard to extend, hard to change. So clean code is also maintainable code. And now that we have stated kind of what clean code is in a very broad sense, the next obvious question is, how do we write clean code? And that's kind of what we are going to try to cover today, at least for a very small portion. Because Clean Code, the book, has more than 15 chapters. And of course, we cannot cover all that. But we are going to be focused on those essential parts that I believe that are very important and fundamental for the front-end developer. One is naming, the easiest thing in software development, if you know what I mean. And the other part is function and components. So functions and components are not exactly the same, but sometimes they are. But even better than that, they share a lot of similarities. And we are going to cover a bit of that. So the components of your code can be the building blocks for your doom or your salvation, depending if you're doing it right or wrong. Um, we are going to start with naming, and naming is very important one, because you can have either bad naming or you can have good naming, and the result of having one of the other could increasingly drastically affect the performance of your work, of your team, and your organization. So having the right names can solve a lot of problems. So bad naming is the worst readability problem. So if you don't use the right way of describing your code, your variables, your functions, you are going to end up having a really hard to read, a really ugly code, really hard to maintain, because bad naming hides intention. When you don't call things by what they are trying to do or what they're doing, you are hiding the intention of that piece of code, that function, that component, that class, whatever you're doing. And that makes it really hard to track, really hard to find, to search, to reason about. Good naming, on the other part, is really hard to write. So finding names is actually an opposite to what we mentioned before, which was obviously a joke. It's really hard, but is make it really easy to read what you're writing, your code, and that's something that we have to keep in mind. Don't give up on naming. Naming is important. It's hard, but it's important. Also, good thing that good naming will have is that it will make your code easy to refactor. How, you will ask? Because when you start naming your pieces of code correctly, your elements, the code will scream to you when it needs to be refactored, because you are going to start noticing that some things are too tangled, and that we are doing many things, and that the code needs maybe to have more refactoring, more separation, more clustering of the concepts, instead having everything together. So that's another good thing about naming. And as I mentioned, bad naming makes really hard collaboration, because if you start naming things the way you will understand it, maybe no one else in the team will know what you did there, even if you know. If you and the broad aspect of this could be using your native language to name things. For example, my native language is Spanish. Imagine if I work in your team and I start naming by variables using Spanish word. But that's just the case. I could use contractions, abbreviations, things that I mean something for me, but doesn't mean anything for the rest of the team. But when you start writing good names, you are not only making simple for everyone to understand what you're doing in your team and to pick up from what you left, but it also is going to deprecate most of the comments that you are going to need to add to your code. You don't need to start explaining everything that you're doing because the names of your functions, of your variables, is going to be um, self-explaining. All right. So that said, let's go and jump through a bit of code and see how naming can change the way we see our components and we understand our components. Here we go. So I don't know if this is big enough. I'm going to just zoom a little bit more just in case. Okay, so let me close all this. We are not here yet. Let's start by order. By the way, this code is shared. It should be, you should have it in the chat. This is an open repo, so you can go there, experiment, fix things that I haven't fixed, understand the steps. I try to make this stepwise, so you can go step by step and see the different the changes and how that affect the code. But that said, let's open this Colossus component. So this Colossus component have some things that you can start noticing immediately. The first one is that, let's start by the name. The name of the file is Colossus, and that really doesn't tell us much, right? So just for giving a bit of context, kind of the domain of this application is the Hercules chore or task or mission that he had to complete, right? So maybe this Colossus was kind of one way of referring to that hard tasks, but it's really not saying anything to us. So it is not something you will easily find in your code if you're finding for a piece of functionality. But then when you start looking, you actually have a different name. Is the name of the component is different than the name of the file, making it even more confusing. So now the name is Hercules Mission, which maybe is a bit more easy to track, right? To is more related to the domain, but still is not revealing intention. We don't know what this component does by your reading Hercules Mission, even is domain related. But that's not the only problem. When we start looking to other pieces of this code, we see that we have some stay here, but it's using some kind of abbreviation, which we don't really know what this is about. By the way, this what this is trying to say is to do's. So you can see that this is really, sorry, my mic just you can see that it's really hard to just figure out by seeing this. What is this doing? You have to start scrolling and reading into more code and more code, and then you get to this effect, and this effect is fetch data. Okay, but what data? And you have a result and data, and everything is so generic and easy to understand. And the best clue that we have about what is this doing is the name of the URL of the API endpoint, which is really not what you want. You don't want to the URL be the description of what you're doing. And if you take a look, it's really hard to, by just looking at this, understand what it's doing. You kind of have an idea. Is doing, now that I mentioned to do, is doing something with to do, is have some completed status. But then now when you go here to your template part, you see that you're iterating over this element and just showing some text or something. So the best right now, the best clue that we have for what this is doing is the API endpoint and maybe some of the titles and subtitles that we are using. But this could not even be there if you're using some kind of internationalization technique. We could have something different here even. But that's the best clue that we have, which is really not what we want. And you may ask, okay, what if we throw some TypeScript to this? Will that make it better? Well, TypeScript by itself is not going to help, because TypeScript is just as good as the name that we use for type. So now we name our type entity, right? Yeah, because why not? It's the entity of our domain, what we are doing, and have some values there. Yes, that give us some kind of idea. But now we just have some list of entities, and we are getting some entity data, and really not much more than that. It's really hard to, even with TypeScript, to reason about what this code is doing. So how can we start like improving a bit of it? And let's go for the JavaScript version of this just first, because I guess that with good naming, you don't even need TypeScript. It has other, TypeScript is really good. Don't take me wrong. I use it everywhere, but has other purpose. It gives you compile time checks, go linting checks about not um, having conflicting ties, or avoiding other kind of errors. But it not necessarily is going to help us read your code or have a clean code. But now we start renaming or functions or components or effects or hooks, and everything start to make more sense. So now we have a shortlist is the name of our component, or previous Colossus or Hercules mission is now shortlist. So that immediately makes you think about what this is going to be about, what is the intention of this component. And now our states are the completed short and uncompleted short. So immediately you know that you have this concept of completed short and completed short. And when you're going to the fetch part, you know that you're fetching for the completed and uncompleted short. So you know that you're getting both. And what you're going to get from that first is the stringified version of it. That then when you convert it from JSON, you're going to have the completed and uncompleted shorts. We could just name it these shorts, but that is only part of the information, right? Don't be afraid of use long names. Long names can be your friend. So if you use long names for explaining everything that is going on and that works, that's great. So here we have the completed and uncompleted shorts, and then we are filtering over that, and we are setting the completed and uncompleted, so everything starts to make sense. So we are not setting the completed shorts. It makes sense that we filter the complete list and just take the ones that are not completed or the ones that are completed respectively. So I want you to take a look and try to think for yourself is how value these good namings have added. And the same happens here when we go to the template, because now we know that this part which says spending is only going to iterate over our uncompleted shorts. And we are going to show some data from that shorts, and the same for the completed ones. So we did nothing. We haven't changed our code. We just changed the names, and everything started to be much clean, much more clear, much more readable and maintainable. And you know what each piece of this code is doing. I don't say it's perfect. There are a lot of things here that we could improve, but there is definitely an improvement. What else? What we can do, and this is something that we are going to be discussing a bit later. So when we start to splitting our code into more small pieces, we also making that part more readable. For example, now here in the template, we extracted our listing and we added a list component. Again, I don't say this is the right way of doing it, and we will go a bit into more deep into this in the next section. But at least we can say that, yeah, this component now reads better. We know that we are listing. It's more declarative in explaining its intentions. And yeah, but list, oh, by the way, list is just what we had before. We are just iterating there. So probably this doesn't worth doing it, but nonetheless, it makes a bit more clear while we are reading this component. However, list is a bit generic. So we are again adding some bit of ambiguity here. And for that, I think it's better to go a bit more and rename that list to be short list. So now we are being very specific about what this list is about. Of course, we could have a generic list that we are going to use in different places, and that will be useful. But in this case, that this is not the case. We are explicitly iterating and showing a list of shorts. So we want to be specific about that. Okay, this is a bit about naming, and there are other lessons that the book Clean Code has and that we can apply to our front end and are related to what we already have seen. And one of those is use intention revealing names. As we saw, when we start like naming things for what they are doing or what they represent or what they are going to display in the HTML and the UI, we are start making ourselves more aware of what the code is doing, and it's going to make it more easy for us to track how to change it if it needs something needs to be extracted. Another one is to avoid disinformation. So this one is about not using abbreviations. So we saw that we were using at the beginning the TS2, the TS1. So these abbreviations don't really are saying much. So we are making this information. Some people may even think that that means something else, like TS is types. So one could think there are types. So let's try to avoid this information. And this is another of the lessons. Another of the lessons is to make meaningful distinctions with names. And what this means is when sometimes you have two things that are kind of similar and could be named the same, we are sometimes tempted to have distinctions by number of letters. For example, we have shortlist 1, shortlist 2. That's not really useful. That's really confusing. What 1 means, what 2 means. But when we do choose using complete shorts and incomplete shorts, both are shorts, but we are making meaningful distinction about why they are different. Another good advice is to do pronounceable names. So it's really interesting how brain and code can combine, right? How we process the code. And one important thing is language. If you start making pronounceable names, you will be much more easier to communicate with yourself, but more important to others. When you want to explain some part of your code, if you have some kind of abbreviation or hard to pronounce names, or you put words in the half, it's going to be very hard to pronounce and to transmit others what are you talking about. In the same line, you should try to make searchable names. So it's more than often that you're going to work in a big source code. And when you're trying to find for particular parts, having good name for your components, for your variables, even that you can use your IDE to look for those and get there, that is going to make your life and your team life much more easier. So try to always make searchable names and try to think when you're creating a name, how will you look for that variable, function, whatever later? Will be the word that you will use to try to find it? And the last but not least advice or lesson that we get from the clean code, all this you can find in the clean code, by the way. We are just trying to extract some of this knowledge and wisdom, but you are definitely want to go there if you want to have more details into all this. But yeah, the last one is to have domain specific name. And domain specific are really great when you're working with stretch collaboration with your clients, with your coworkers, because you will find a thing, and you can learn more about this in domain driven design, which is another great book. We can get there in another day. But when you are having a singular ubiquitous language that everyone relates to, it's going to be much more easier to translate domain requirements to code, and vice versa. It's going to be easy to speak to the clients or your co-workers about things that are named a single way than when you have difference between how you represent things in the code and how are called in the real life. So that's for naming for now. And naming is really great. Again, I encourage you to go back to the book and go over chapter 2, which is naming. But now we are going to move a bit forward, and we are going to start to, without forgetting that, applying a bit of the lessons that we have found there for functions and components. And just a second to hydrate myself. Okay, so previously we mentioned that functions and components are not exactly the same, although in some modern frameworks like React, they actually are the same. So components are functions. Not that functions are components, but components are functions. But even if you don't have this kind of frameworks, you still go and do um, very quick comparison about how they similar, how similar they are, because components and function, they both have inputs or could have inputs, and they both have do some kind of internal processing, and then they through an output. In the case of component, that output is going to be the template that we are going to visualize in the browser. So most of the lessons that clean code has for functions, we can start applying for components, and it's really easy how you can see that how easy you can apply those. um, so the first lesson or the first core of what a function should be is that functions and components should be small. And what is small? Can we come up with a number about lines of code that small means? Well, Uncle Bob has his opinion on this, and he actually have a name, but I believe that's the less interesting part. And we are not really interested in providing any number here. We are more interested in the thought process, the principles that take us to create small components, how we can create small component, how we can take everything from a component that we say, okay, this or function, and say, okay, this is small. And before going that way, let's see how a big component looks like and see what are the problems with this. So let's go back to our code. And now we are going to go to our functions and components section. So this is going to be similar to what we've seen before. So it's using kind of the same concept, but we added a bit more of logic, which is very similar, more similar to what you're going to have in your code. So this is let's say 440 lines component. Is not that long, kind of long, but it's not that long. You will say there are much more bigger components, but even you may say that this is not that big in lines of current terms. Let's start looking at this component and find out that it is really hard to comprehend everything that this component is doing, and what it's doing, how it's doing it. So again, now we have our completed and uncompleted shores. Okay, we have that state, we have our list from before, but then we have a filter term, and we have a search functionality, and we have a complete short method, which is quite big, kind of, and we have an incomplete, which I will say they are similar. They say similar, but it's kind of hard to tell. And okay, we can live with that. But then we have filtering, and we have fetching again. And you get what I mean. It is really hard, at least for me. I wrote all this, and now that I scrolling through, it is kind of hard to understand how all these work together, what everything that this component is doing, and how changing one of these will affect the other parts of it. And if we go to the template, you will see that, okay, now we are showing whatever we have from here. And we have a search part here, and we have also a filtering listing part. So previous lists now have is the same, but filtering. And we are also doing some syncing or input here to process. I guess that, yeah, when we completed or uncompleted. So we kind of, because we have good naming, we kind of understand everything that this is doing. But now it's hard to changes. It's hard to realize how everything glues together and what happens if I change something. So definitely, if this component was small, that would be better for us to understand everything that is doing. And that's the problem with big components. So how do we get there? And one of the most interesting lessons of the book, and this actually is one pattern coming from Linux, is that functions should do and components should do one thing, do it well, and do it only. So, what is one thing, you may ask? So, what is doing one thing means? And the one of the best way of describing it, or not the only, but definitely some important one, is that functions and components should have only one level of abstraction. So we will try to avoid mixing levels of abstraction. And mixing levels of abstraction means that we are doing things in a lower level, like fetching endpoints. Middle level maybe is gluing a bit of stuff, and the high level is like having an overall view of what everything that is doing one component and or function. So if we have all these level mixed up, we should try to separate and have different component, different functions to get to that place. Our components should also tell a story. So when you're reading your component should be organized in a way that kind of reads the recipe, the script of what you're doing. And we can do that by extracting bits of code and adding names to that, new names. And new names bring with it semantic value. So this separation will also take us much more closer to declarative programming, and we will start to see your functions as a list of a script where we start reading what we are doing, and then we read every little step by separate about what they are doing. And if you need to know how that little step is, you go to that place, and that place will be very scope about that particular abstraction level, and you only need to focus on that if you need to go there. So another way of seeing this from the declarative programming points view and the semantic value is in your template part, when you start having like small components separated, and that small component also bring a name, and you have the to-do item. Just for making an example, I'm not saying that that's the way you should do it always, but you start like seeing some patterns, and you start to read more about how the whole functionality in his highest magnitude is composed by little step doing different stuff. And one way of doing this suggested by the book, this is just a suggestion, it's not something that we should apply always, but it helps in some cases, is to extract blocks, and blocks are loops, conditional, try catch. So those are mostly composed of two parts. The loops have the looping part and then have the content of the block, which is what do you do in each of these loops. The conditional is the same. You have the condition for doing something, and then you have what you're doing. And all these bring us back to the one thing and do it well. So if we can extract all this part, we will make our code much more cleaner and make the intentions clearer. We are going to see about this in the code in a second. Other of the suggestions that Uncle Bob has for us is to try to reduce as maximum the arguments and outputs of our function hooks and components. Components outputs are mostly one, is the HTML, but our hooks we can throw out different things from the hooks, which make it hard to understand what that many things are doing. And with the arguments, it does apply to both function hooks and components, because if we start adding too many arguments to our component, it's going to be hard to at some points understand what each of those arguments are making, how those are changing your component. And actually it's probably an indication, if you have many arguments, that your component or your function is doing many things. So that said, let's jump back again to our code and let's see a bit of these components in action. How can we apply some of this lesson to make our code more readable? So here in our initial big component, we say that there are a lot of things going on. So we are not just doing one thing. And the first thing that you could do to make our life easier and the code more readable and clean is to make a distinction between the abstraction levels and the separation of concerns of this component, and make that this component should only visualize the template, should only handle the events and pass it to someone else to do whatever it needs to do. But the component itself, its main purpose is to present the content to the UI. So one thing that we can immediately do to make our life a bit easier is to extract all that crazy logic that we have into a custom hook. So this custom hook is not perfect by any stretch of imagination. This custom hook have a lot of returns element, and we can simply see that this is doing a lot. Actually, if we go to our custom hook, we realize that again we have a hook of almost 100 lines. So we are still having a lot of problems here. But from our component perspective, we are doing just one thing. We are visualizing whatever this entity here is doing for us, this hook is doing for us. We are visualizing what that's returning. So we are doing only one thing, and that's visualizing that and adding some event hooks for the user interaction. That's all that we are doing here. And that makes our component, I will say, in my opinion, very much more clean, very much more readable, and much more small. So we went from 140 lines of code to 58. That's quite an improvement. Now, there are some school of thought. There are many arguments. So everything depends in software development. That's something that we all be aware at this point, that everything depends. There is not a silver bullet. So for some people, having in separate files these kind of separations is a bit counterintuitive, because it's hard to be jumping from one file to another if you are working in things that are strictly related, like this one, for example. But my point on that is that even if you have it in the same file, you will probably end up doing something like that. You will probably end up like opening the the file in two tabs now with modern IDs and some regular decent monitor, you can start splitting your code, and you will don't end up doing something like that. One part of the concerns will be in one screen while the other will be in the other tab, sorry. So why don't just splitting it up and having different files, and you will end up doing the same thing, you will have it split. So that's a little tip that I will say if you are wonder about this thing. But both recommendations have something in common. You have keep things that change at different rate. You should keep it together, and that's the single responsibility principle. But that's another book as well. All right, so now we make our component a bit cleaner, but still there are some parts that are hard to reason about, and there are, you could argue that this component is doing multiple things. For example, we are searching and changing the search and updating the value of this input. We are listing our components or short, sorry, or the incompleted and the completed ones. And for each one of these components, we are making some actions, and that actions are actually making a lot complicated or short states, because we need to manage not only the high level short list, which is what this component is interested in, like the completed list and the incompleted list, but we also need to manage the little pieces inside it. Each to do has its own state, and now we need to manage that together and set the completion of the independent shorts at the same time that we are updating the list big short. And that actually makes it hard to read and reason about, and those are our independent things. So the next thing that we can do is to have our short item component. So we can extract that. Let me close this a little bit. Just we can extract that, and now we have new words and new names, and we are going to make more clear what the previous code was doing. We have, by the way, sorry, I might go too fast with this. This is the short item component, and just for you can see it very quickly, we just extracted a piece of this code in the template, and we are, for each iteration, we are now representing this with that short item. Do we have to do this all the time? Of course not. If we are only showing some kind of random text, like in the previous example with the names, this is not necessary. But this is doing much more. It has its own state. It has its own integration. It's doing more complex things. So now our short item component is going to have two tasks. It's going to optimistically complete the short and optimistically incomplete the short. And just by having these names, we are more aware of what this code is doing, because now we know that we need to emit an event when the short is completed. And what this is going to do is tell the father component, the parent component, hey, I'm doing this, do whatever you need to do with this information, right? But we are not modifying the parent state from inside here. We are modifying the state that correspond to this little short item. Then we are doing a fetch. And if the fetch fails, we are going to incomplete the action. So why that's what is optimistically, because we are going to complete it before we know if the server update was correctly or not. Then we are going to do the update, and if something went wrong, but we are optimistically it's not, but if something went wrong, we are going to roll back our changes. And this is very, very useful for, this provides a very good UX. So it's definitely something that we want to try. And we were doing this before, but since everything was convoluted, it was really hard to understand it. Right, so this is what our component is doing, is just toggling the short, right? We are toggling the short, if it's completed, if it's not completed, and we already handled this. Probably we are missing here some use state for changing this element here. But no, we are doing that outside here. Yeah, remember, because we only receive an immutable part of our data. And that's another interesting topic, immutability and side effects. So the component is still going to manage to do all this complete and uncompleted, but we are dealing with all the specific part of fetching that in the server and verifying if everything went okay. What this is going to do is going to also make our short stay much more cleaner, because now we have that our complete and incomplete short doesn't care about looking for the server for this particular item or not. It only cares about put it in the right list. And additionally, it's doing something else, which is putting the complete status. But let's say that this is the single source of truth, so kind of is okay. But of course, this is not a perfect code. This is example code. We can go and tweak it as much as we can. The important thing is that by just doing this, we make both our short template code more clean and our short state more clean as well. However, this is still doing a bit more than it should. And we should be looking at, especially this short state. This is doing a lot of things. This is still filtering, searching, completing and completing, managing the list. That's not what we want. So what we are going to do now is, initially we are going to, oh yeah, I forgot. So yeah, something else that we were doing is that we were having our state or presentational and data management logic in the same place. So we just did another one more step in this check hidden, and we extracted in a sure toggle. So now all this data is in this way, and in its own hook, sorry, and the sure item only cares about listening to that entity that is managing the data, and just having the single responsibility, doing only one thing, which is displaying that content to the user and passing the user interactions with the UI. That's all that it should be doing, and this only what it's doing. And at the same way, we added a bit more of folder structure, which is going to always make our code more organized, and we are going to still have things that are related close to each other, but things that are even more related, even closer, right? And that's kind of what we are achieving with that. But now we saw that our shore was doing different things. It was handling also the searching and filtering, and the hook was doing, and a single hook was doing all this. So now we can even do more separation of concerns and going more in the direction of doing one thing. So now we have two hooks here. We have the short state, which is only going to manage the completion and uncompletion of a short and showing the two lists that we are going to display. And then we have a filtering hook. And this hook is going to be listening to search event, and it's going to give us a filter, to filter list. So we are doing the same thing, but we are doing it separately. And now we have this hook is doing one thing and one thing only, and this hook is doing one thing and one thing only. And that will allow us to untangle all we do. And we know that if we modify something here, it's completely unaware of what this is doing here. So we can easily modify each of these hooks independently. And we can take a look at that right now before going to the template. So now short filters is going to return filter shorts function, and it's going to return the filter shorts. So this is the callback that our UI is going to utilize. And it's just filtering. It's just doing what it's named to do, is handling filtering. It's everything that it does. And that's the way we want our hooks to do. Okay, now that our hooks are separated, we also want to keep the searching state apart. And we are going to create this short search bar component. And notice that this is only handling these filter source when a new search occurs. So this is not directly modifying the state of the parent. It's just accepting a callback, a way of notifying the parent, hey, something happened, do what you need to do with this. And just to take a look at this component, this is a very simple component, but at the same time, it has its own state. It's doing one thing. It should be separated. It has its own responsibility, which is handling the search state, like filtering, setting the filtering, and whenever a change occurs, is going to untangle the event, is going to um, extract the event, and is going to set its own state, and is also going to notify the parent component. And this is small. This is what we are looking. Small components, small functions are more easy to understand, are more easy to reason about. And that's kind of course, there is a lot more to do here, but I just wanted to show you how this little step make our components easier and easier. And now the component is now smaller than at the beginning, but it's also much more declarative and much more easy to reason about. And each piece of the functionality is separated in its own hooks. So that's what the lesson, the big lesson behind it. Even this code is not perfect. I mean, I don't even tested this code. I don't know if it even works, but I quite confident now that I see it split it into pieces that is kind of doing what it's supposed to do, right? Um, so that's another benefit. All right. So now that we are in this point, let's talk about some other lessons that the book has for us. And let's talk about dry versus wet versus aha and Jagni. We are developers. We love our abbreviations. So I also dry. So let me get my throat wet and have some water. All right. So if you are not familiar with this concept, dry means don't repeat yourself. And we are going to each one of these independently in a second. Wet is write everything twice. Aha is avoid hasty abstractions. And Jagni is you ain't gonna need it. I don't going to even try to name the authors of these acronyms. Some of those are not even clear. So let's just focus on what they say. Let's start with dry because dry is the one that is much more suggested in the clean code book. And dry is telling you that you should never have repeat your code. You don't ever have code repeated. You should try to abstract it and have it in a single place. And what I'm going to do, tell by this one, applies to the rest as well. All of these terms are a bit dogmatic by itself, but they all have wisdom. And it's our job to try to find when they are really useful and when the wisdom they transmit we should apply. For the try, what is really telling us and what we should be paying attention is that when we have multiple logic repeated across our source code and that logic is kind of complex most of the time, you want to extract that. You want to have that complex logic extracted into a single place. That way, you have to fix a book in one of those things. You have to fix it in only one place. You don't have to fix it in 8, 2, 3, 4, 5, 6, 8 places. You also going to be much more easy to reason about changes when you split piece of code into a common place in an abstracted way. Now, that said, do you always want to do this or you want to abstract beforehand even without having duplication, even without having complex duplication. Well, that's what all these other terms are telling us, is like they all work together. They are not exclusive. The wet term is going to write everything twice. So basically the lesson behind this one is that you don't want to start abstracting before even having repeated code. You don't try to plan for the future, because abstraction have a cost, and it's nothing comes for free, and abstraction can be really complex in some cases, and if you're doing it without even needing it, that's a problem. So at least write everything twice, and maybe wait for a third time, or even the second time to see that this logic should be better in one place, because this will be easier to fix if something comes up. Then do it, but at least have it write it twice before start making this decision. The aha is avoid hasty abstractions, and the main philosophy is very similar to what we have been discussing, is to only start abstracting when you really need it. Even if you find the code repeated in 3 4 places, if that code is not dangerous, or if that dangerous, I mean, is not too complex that it is hard to make those abstractions, or these abstractions are going to be most costly than actually having this little duplicated code everywhere, or if you think that this part may change independently, and then the abstraction will become too complex because you are going to have many ways of changing the parameters to accommodate to all different scenarios. That's a problem, and that's what aha is about. It's about avoiding hasty abstraction. And related to all these ones, you have the try, or sorry, the jagni, which is you ain't gonna need it. So it's kind of in the spirit of all the others. Don't do abstraction beforehand. Don't do abstraction until the code starts screaming to you, this is painful to maintain, having it split in so many different places. Please, let's have a single way of handling with all this. If the code is not screaming to you, and I know that this screaming is also related to the intuition we were talking about earlier, you don't need to do this abstraction. But abstractions are great, so dry is a good principle, but also the others. Find your balance. So another thing is that another lesson is that function and component should have no side effects, or at least we should try to avoid it. It is not always possible, but side effects are really, really nasty when it comes to debug and finding problems and creating problems in this case. So as we saw in our examples, we should try never to modify a state outside of our components or functions. Instead, a good way of doing it will be probably having a callback function or dispatching an action, making explicit the change that are happening in our components. Because one way, and this is one way probably some people don't like to use the React context, is the React context can be very easy used for hiding operation that affect other parts of your system, of your component system, of your application, and it's going to be very hard to find out where that change occurred. So that's when patterns like Redux and more than Redux, the action event or state machines, or even callback functions came into place, because those are explicit ways of telling, hey, something is changing, or I doing something, notifying you to do something. You do with this information whatever you want, but you change your own state. And another one of this related lesson that we have is the command query separation. And the command query separation is all about extracting part of the code that reads from the piece of code that writes, and or make alteration to the state. And one way of applying it for components is to have container components and presentational components. So you have a component that the container component that doesn't have much more UI value. It's mostly a shell for other components, but it will handle everything of your logic. And you have, in the other hand, the presentational component, which is mostly about receiving value, reading those values, and showing those values to the user. But there are other ways of applying that. The container and presentational component is a very good pattern, and I use it a lot. But with React, we can also use other patterns like extracting all these into hooks, and the hooks, custom hooks. And these hooks are the ones that are going to do this command part, this modification of the state part, and the components per se is going to be only worrying about presenting. So this is some of the lessons that we found in the clean code. I hope this can help you see what naming and having small components will help to make your code clean and much more easy to reason about and maintain. So if you have any doubts, if you want to go deeper, you can find me in Twitter, and we can continue the conversation. This is a broad, very broad group of lessons and teachings in the book I'm meaning, and not all of them are applicable, I think, to modern programming, but most of them are. So I truly recommend you to go over this book. And there are other books. There is the Killing Architecture books, which is going to cover a bit more of the high level organization of the code. The Blue Book, the domain driven design. There is also one great talk from one of my co-this daughters, which is RoboCell, and he has a great talk about components and how to avoid pitfalls, and it's very related to everything that we talked to today here. So I will also recommend to look that one. And that's it. This is the end, folks. I hope that you have learned something today. If any of you learned something, I'm happy with that. And see you in the next one.
Thank you so much, Nacho. That was an amazing presentation. We don't have any Q&A at the moment. If you want to drop your questions in here at a later date, better to get Nacho on Twitter, but we'll do our best to get back and answer some of these questions. But again, thank you so much for joining us. Nacho, thank you so much for your presentation. And hopefully we will see you all tomorrow. Anthony Fu is going, we're going to release his recording at 11 a.m. Eastern time. So set your alarm, set your clocks. We will be on YouTube. Anthony Fu is going to present Vite training. So come back tomorrow. More questions, keep them, drop them in there. We'll get back and we will see y'all soon. Bye, everyone.
Bye-bye.